The window-to-wall ratio is used to determine the optimum amount of glazing that is needed for a specific climate and orientation. Heat loss and gain through glazing is a large factor in our thermal comfort, and by controlling the correct amount of glazing in relation to the wall, architects are able to create the ideal comfort scenarios without relying on active heating or cooling systems. The ratio is all about thermal comfort and energy usage, implying that the two factors are coherent in many ways. The ratio is extremely simple. It is the proportion and orientation of exterior wall surface area that is glazed. In other words, the net glazing area divided by the gross wall area. The window-to-wall ratio is determined by dynamic thermal simulation methods to assess a building's performance. The simulations that will be conducted to conclude the ideal window-to-wall ratio is with the help of MIT's Sustainable Design Lab UMI plugin. This plugin is ideal for architects in the workplace to model different windows-to-wall ratios within a location to find the ideal energy comfort levels in different volumes. The simulation depends on a building's volume, the number of floors that the building has, the structural material it is, and the proximity it has to other buildings. To start with the control, I used a building in Boston that has a floor height of 3 meters and an area of 36 meters squared, with all the window-to-wall ratios being 40%. The total operational energy ended up being 191 kilowatts per meter squared with wood construction. This is a simulation with all different types of glazing options. The first is 90% glazing in the south, and the rest is 10%. The operational energy for this building is 161 kilowatts per meter squared. This is the best option in comparison with others. The next was 90% glazing on the east, west, and north, and with 10% to the south. This was the second worst with 234 kilowatts per meter squared. The next was a good middle ground and probably the best option with 30% on all sides but the south. The south is 60% glazing, making the building's energy usage 182 kilowatts per meter squared. The next is a building with a glass ceiling, and it was surprisingly efficient, being 153 kilowatts per meter squared. The last is the worst by making a glass box. This took the operational energy to 243 kilowatts per meter squared. The final simulation is one where the volume changes. The building that is the tallest and has all glazing is the worst, with its energy usage needing to operate being 283 kilowatts per meter squared. It also affects the buildings around it, with the building more north to it needing more energy to operate. The Value by MVRDV Architects is a project that collaborated with ARC Amsterdam to create a parametric tool to determine the best window-to-wall ratios for the unique volume. This allowed the firm to have control over the daylight and sunlighting, structural limitations, privacy, and more. This made each and every apartment completely unique from one another. This study shows how orientation and material can shape spaces into unique, distinct forms depending on the ideal operational energy. This study also shows how the ratio can be complex and exciting, by allowing each space to be the best form of itself depending on its energy usage and window ratios.